Hi students, welcome to LAKSHYAA Academy YouTube channel. So today I am going to explain transistor as an amplifier. There are two types of transistors, NPN transistor and PNP transistor. In NPN transistor, the majority charge carriers are electrons. In PNP transistor, the charge carriers are holes. In general, the mobility of electrons is more than that of mobility of holes. Today's concept, transistor as an amplifier. PNP transistor or NPN transistor as an amplifier. Transistor can be used as an amplifier. Transistor can be used as an electronic switch. What is meant by amplifier? Already we discussed the transistor concept. A device which is used for increasing the amplitude of alternating voltage or alternating current or alternating power is called amplifier. Okay, if the input signal is AC, the instrument or the device which can be used to increase the amplitude of alternating current or alternating voltage or power is called as amplifier. So transistor can be used as an amplifier. Explanation of amplifier using an NPN transistor in common emitter configuration. So among common base configuration, common collector configuration, common emitter configuration, in most of the cases they prefer common emitter configuration because here we consider common emitter configuration of NPN transistor. A circuit diagram of NPN transistor in common emitter configuration. So in common emitter configuration, emitter is common to both input and output. Input is measured across base and emitter, and output is measured across collector and emitter. Okay, so the emitter base junction is in forward bias condition and collector junction is in reverse bias condition. And the base is connected to a variable battery. In some of the books it is mentioned as EBB also. Here I mention it as VBB, and output battery is VCC. So here I mentioned that emitter base junction is in forward bias condition and base is p-type semiconductor. So p-type semiconductor is connected to positive terminal of the battery. So Base junction is in forward bias condition, and here collector is n-type semiconductor. So n-type semiconductor is connected to positive terminal of the battery. It implies that it is in a reverse bias condition. So collector junction is in a reverse bias condition. And IB represents the base current, and IE represents the emitter current, and IC represents the collector current. In the case of NPN transistor, the direction of conventional current is from base to emitter. So here RC or RL is load resistance. Okay, base resistance RB. A circuit diagram of NPN transistor in common emitter configuration. So RL represents the load resistor connected in the output circuit. It means collector circuit. The input circuit is forward biased with the battery VBB, and the output circuit is reverse biased with a battery VCC. Emitter is common to both input and output. Okay, so load resistance connected in the output circuit is denoted by RL or RC also. In some of the books they mention that RC also. Yeah, how it works as amplifier. Students, there are two cases. In first case, I consider no AC signal. That means no AC signal voltage is applied in the input. When there is no AC in the input, the emitter current, base current, and collector current can be given by IE equal to IB plus IC. In any transistor, IE equal to IB plus IC, and IE represents for emitter current, IB represents for base current, IC represents for collector current. So IE equal to IB plus IC can be written on the basis of Kirchhoff's first law. Kirchhoff's first law is also named as Kirchhoff's current law. You learn in current electricity chapter. So according to Kirchhoff's second law, Kirchhoff's loop law, in a closed circuit, the net EMFs can be written. So for the output circuit, we can write VCC equal to VCE plus IC into RL. Voltage IC into RL means voltage drop across load resistance. In the load resistance RL, a current IC is passing. So according to Ohm's law, in a conductor, if a current I is passing through it, according to Ohm's law, we can write V equal to I into R. The potential difference across the conductor is equal to product of current into resistance of that conductor. So here RL is load resistance. In the load resistance, a current IC is allowing. So voltage drop across RL is given by IC into RC. VCE represents voltage across collector and emitter. So the sum of VCE and IC into RL gives the potential of collector battery VCC. So VCC equal to VCE plus IC into RC or RL. So from this mathematical expression, anyone can able to write VCE equal to VCC minus IC into RL. Note down, VCE equal to VCC minus IC into RL. We can analyze this mathematical expression. Yeah, in the second case, the input signal is AC, alternating current, alternating source. So AC signal is applied to the input circuit. So if AC signal is applied in the input circuit, obviously there is a change in the emitter base voltage. So because of change in the emitter base voltage, emitter current also changes. So if emitter current changes, consequently collector current also changes from IE equal to IB plus IC. Yeah, when the input signal is AC, there is a change in the base emitter voltage, hence there is a change in emitter current. So as emitter current changes, obviously collector current also changes. And according to Kirchhoff's second law, we can write VCE equal to VCC minus IC into RL. So in this expression, what happens if IC changes? So if IC changes, it results that VCE also changes. For example, VCE equal to VCC minus IC into RL. For example, 10 equal to 8 minus 2. This value increases, this value becomes 3, 8 minus 3 equal to 5. So if IC increases, this total factor increases and VCE decreases. So finally, we can conclude that as the collector current changes, the collector voltage also changes because VCC is fixed. This is the fixed value. So with the change of IC, we can observe the change in VCE also. So the change in the collector voltage appears to be amplified output. Amplified output of the input variation. So for an amplifier, we can define current gain, voltage gain and power gain. Already in the previous videos and I mentioned that you know that. So current gain is nothing but the change in output current to the input current, and it is denoted by beta in common emitter configuration. So beta equal to change in collector current by change in base current. For AC, beta equal to delta IC by delta IB. For direct current, beta equal to IC by IB. This is current gain, and the value of beta ranges from 20 to 500. Already you know that. Yeah, change in like that, the change in output voltage to the input voltage is called as voltage gain. Generally, voltage gain is denoted by AV. So AV equal to output voltage by input voltage, or delta VCE by delta delta V input, or R into delta IB, where R is input resistance, or AV equal to minus beta into RL by R. This negative sign indicates that the output voltage is opposite to the input. So opposite with the phase of input voltage, input and output are out of phase by 180 degrees. So this phase difference you can learn perfectly in AC circuits. So input and output are out of phase by 180 degrees. Negative sign indicates that output voltage is opposite with the phase of input voltage. Yeah, power gain. The product of the current gain and the voltage gain is nothing but the power gain. Our power gain is also defined as the rate of change in output power to the input change in input power. Power gain is denoted by AP. AP equal to beta into AV. All these parameters we discussed. Yeah, I have given one of the problem for our understanding. For a common emitter transistor amplifier, the audio signal voltage across the collector resistance of 2 kilo ohm is 2 volt. Current amplification factor is 100. Find the input signal voltage and base current if the base resistance is 1 kilo. Here R0 is given, collector resistance RC or RL 2 kilo ohm, 2000 ohms. And output voltage is given as 2 volts. Beta is given as 100 and input resistance is given as 1 kilo ohm, that is base resistance 1 kilo ohm. So from this we have to calculate the input voltage. We know that AV equal to output voltage by input voltage, that equal to beta into R0 by Ri. So 2 by Vi equal to 100 into 2000 by 1000. So 2 by Vi equal to 200. Vi equal to 2 by 200. So 0.01 volt. Yeah, base current equal to input voltage by input resistance according to Ohm's law, Vi by Ri. So 0.01 volt by 1000. So this is 10 power minus 5, 10 into 10 power minus 6 ampere, 10 microampere. Yeah, next second problem here. Two amplifiers are connected one after the other in series, that means cascaded. The first amplifier has a voltage gain of 10 and the second has voltage gain of 20. Input signal is 0.01 volt. Calculate the output. Yeah, here two amplifiers are using with different voltage gains. So total voltage gain equal to AV1 into AV2, which is output voltage by input voltage. So output voltage equal to AV1 into AV2 into delta VI, 0.01 into 10 into 20. So simplify that, 2 volts. Yeah, once again I am giving for our noting purpose the gains in common emitter configuration, common emitter amplifier. Once again I summarize all these: current gain, voltage gain. Okay, here a new parameter GM. I explain that. The transconductance The ratio of small change in collector current to the corresponding change in input voltage. And when constant collector voltage is called as transconductance, it is denoted by Gm. Transconductance is the ratio of change in collector current to the change in input voltage when output voltage is kept constant. So it is denoted by Gm. It is denoted by Gm. Gm equal to delta IC by delta VB at VCE equal to constant, or Gm can be written as beta by Ri, because this is input voltage. Input voltage V equal to, according to Ohm's law, input current into input resistance. Okay, so IB into Ri, delta IC by delta IB gives beta, so Gm equal to beta by input resistance. Okay, next, relation between alpha, beta and gamma. You know that alpha is current amplification factor in common base configuration, and beta is current amplification factor in common emitter configuration, and gamma is current amplification factor in common collector configuration. Alpha equal to beta by 1 plus beta. Thank you.